Morning. I don't know about you guys, but today I'm in a mood for math. So, let's learn what derivative is and how to take it. A derivative is just a function's slope. Not the slope between 2 points, but the actual function's slope. So, the slope between 2 points would be rise over run. In a function, that's simply your change in y over your change in x. Or you could say your function at some later point minus your original function over how far between those 2 points are. Now, in a derivative, the change of how far those 2 points are becomes almost zero. We'll say it's the limit as this term h approaches zero. So that means simply a derivative of this function to the limit as h tends to 0 of your function at some later date minus your original function over this very, very, very small change that we're looking at. Kind of seems like mumbo jumbo, but let's break it down. Let's find out what she means. Let's look at a function. Let's look at the function x cubed. Right? This function, most people know it starts at infinity in the positive. Oh, let's redo that. That was awful. Starts in infinity and positive, comes around, and then goes down. There you go. Much better. Ends at negative infinity, goes to infinity. You can see at some point at 0, its slope is 0. This means that the slope of this function is changing. Let's understand how it's changing by taking its derivative. So we'll just take our function and simply plug it into our derivative formula. Our derivative formula is saying that everywhere you see x, you replace it with x plus h for this first term. Second one, you leave your function as it is, and in the bottom, you just divide by h. So the derivative of x cubed, our derivative, would equal this x plus h all cubed minus x cubed over h as the limit of h approaches 0. Looking at this, if we were to put our variable of h as 0 in, you would get both 0 over 0, because inside of the parentheses you'd get left with x cubed minus x cubed, and then on the bottom you'd have 0. 0 over 0 is trivial. We don't want that. 1 over 0, we also don't want that, because you can't define 1 divided by 0. 0 over 1, however, or anything like that, we can deal with. Now, before we give up, let's expand these and find out what happens. Let's pre up the chalkboard first. So our derivative is the limit as h approaches 0, x plus h all cubed minus x cubed over h. If we expand this, we get x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed all over h. Our derivative is equal to the limit as h tends to 0. You can see in this, if we put our h again as 0, we once again get 0 on the bottom. Probably don't want to do that. On the top, you can see this would cancel, and then you get zeros again. But acknowledging that, if these two do cancel, just straight out, now we're just left with h terms and an h on the bottom. We can get rid of the h on the bottom, get rid of some on the top, and then look at what we have. So our derivative, the limit, is h tends to 0 on 3x squared plus 3xh plus h squared. So if we run our derivative, if we run the h now, this becomes 0, this becomes 0, and now we're left with 3x squared. Our derivative of x is equal to 3x squared. The derivative of x cubed is equal to 3x squared. And on this, at 0, if we put 0 in here, we will get a slope of 0. I hope that made sense.